Hi, everyone, and welcome to today's SQL Office Hours. I'm really pleased to have Rick Van Dyke join us again today. He's like I say, hugely knowledgeable guy, great talker, and today he's going to be talking about the with clause or common table expressions, as they're also known. So with that, Rick, take it away.
All right. Well, thanks everybody for showing up. I guess I didn't scare everybody away in my first talk, so
Yeah.
glad you came back or some new folks. That's great. So yeah, let's get with it, so to speak, and talk about CTEs, common table expressions, and we'll focus on how to use them for performance, which is probably the main reason most people even look to use these things, although they do have some other uses. So let's talk about that. So why use them? Well, first bullet point, their common table expressions can have a dramatic impact on performance. I can't really overstate some of the amazing results I've seen for myself when I've optimized a query using these or other folks. It's just incredible. I mean, I've seen queries, no joke, go from never completing to completing in less than 10 or 15 minutes. It's just in a rather I don't even know how to say it. It's just amazing what they can do. Now, caveat, of course, they don't always do that. If you just because you use a CTE doesn't mean you're automatically going to get better performance. It's got to be used the right way. Like any tool can be misused, and of course, you can make things worse. So you got to, use it the right way and all that kind of stuff, which hopefully I'll give you some hints about where places that these are likely to use, even though this is a pretty short presentation. The other cool thing about them is it can just make code easier to read. Um, this isn't really a common use for them, but I've had a few queries over the years where the query didn't really run a lot better per se, just because CTEs were used. But boy, it was a lot easier to understand because the code was pretty complicated. There's a lot of pieces and parts. And by the coder putting it into these chunks that were very easy to read and then pushing those all together in the main query, boy, it really worked well. It ran fine, and it because of the way the optimizer chose to push everything back together, it really became just one query that was running. So the CTs kind of disappeared, but it was so easy to read that it made it very easy for us to debug it. And so the gal that was managing this one in particular that I remember was having problems with one of the CTEs. And we found, it was very easy to just focus on that one and fix it. Where if it had been one massive query with all these tables, oh boy, it can get really confusing really fast. So that's another good use of these. And also the next point, it can make code easier to reuse too. So I've got a CTE that's something that I want to use in other queries. And maybe I need to modify it a little bit, because yeah, I want this same basic data, but a little, hey, boom, just copy that thing over, modify it, presto, away you go. So very easy to do. Also, these are not new. They've been around for many years, 9.2, which is a couple hundred years in Oracle time. So, they've been around for a while, and they've been enhanced quite a bit over these years. So they're really a great tool to add to your kit if you're not using them already. Now, as Chris mentioned, the with clause, and my joke, of course, get with it. So let's use the with clause, and that's how you write these things. Uh, Talk about some syntaxy things and whatnot. But you start off with the word with, and then you can define multiple CTEs inside the with clause. So generally speaking, there's going to be one with clause in a statement, but there can be many CTEs inside that. And the goal here is that we're going to write something in this CTE that will be something that was previously typically over and over executed. So something that was repeatedly executed in our main query, we're going to pull it out, put it into CTE and execute it once. And that's typically where our performance gains are really going to come in. And that third bullet point just avoids that rereading, re-executing of that block over and over and over. And that's where you're going to get these pretty amazing performance improvements. Now, With that, by the way, you typically only see these amazing performance gains when you have a huge amount of data. If you use the emp and dep table, right? 14 rows and 4 rows, whoop-de-doo-dah, you put a CT in, you won't see any difference, right? It's no better. But if you had millions or billions of rows that were on one or two of the tables and you start using these things, that's when it really comes in. And we'll talk about this materialize thing. Sounds very fancy. It sort of is, but not really. So we'll talk about that as we go along. So let's get into the syntax of it. So here's kind of a syntaxy diagram thing. So we've got the with, and then you name the CTE, use the keyword as, and then you have the select statement. So if you sit back and think about this for a second, you realize really that's a view definition, right? If we used, instead of the word with, if we put create or replace view, name the view as, and a select statement. That's a view definition. So boom, that's really what it is. At least syntactically, that's what it is. And it is temporary in the sense that once this statement completes, poof, the CTE disappears. You cannot refer to a CTE in a new statement unless that statement has that CTE defined in it. Okay. It is only for this moment that this statement runs. We'll talk about again that materialize hint that you see there in the statement. So get into that in just a second. Just want to make a few comments about the naming of your CTEs. I would generally very much recommend you name them useful names, not like what I show here. Subquery one, okay, what's that mean? Nothing. We'll see a kind of a slightly better example in the next slide. But and also put underscore CT as the suffix on the name. It just makes it easier readability in the main query because we're going to use these in the main query. And it helps identify, hey, that's a table, that's a CT, just like we put or VL or VW at the end of a view definition a lot of times helps us know, oh, that's a view we're selecting from. This list helps us let us know it's a CTE. Doesn't, Oracle doesn't care. You can name them anything you want. But if you want to be able to read your own code, try and help yourself, put some nice names in there so you have a clue what the thing is about. And this CTE thing can just help readability as well. So here, showing a more slightly better example, and I am using good old emp and dep tables. So honestly, running this query with the CTE or not is probably not going to make a much difference in performance because the tables are so small. But you can see there's with, and then you've got emp count. Oh, okay. So if I know my own schema, I know, okay, I probably got this emp table. I'm doing some sort of count on that. Okay, that's nice. Oh, and by the way, it's a CTE. So when I see it later on, down at the bottom, or in the middle there where red arrow is, oh, look, emp count CTE. Oh, okay, I know that's a CTE. I could look up the query because CTEs are defined before the main query. I look up and there it is. And I know where to look for that thing, that object in my from clause. So that's why I encourage you to name them CTs. Now, obviously, with this little query, this is easy to read. There's nothing about it. But how many of you really working with queries this small? Okay, none of you, right? Okay. So you're working with a query that's a couple hundred lines long and stuff, and there might be 5 or 6 different CTEs and all kinds of stuff going on, unions, and you got it. Yeah, that's where this naming convention can be very helpful to make it quicker to read the query and know who's who in the zoo. So that's why I encourage you to do that. Um, Now, this is also a good example of when CTEs would typically be of benefit because without a CTE, I probably would have written this with a correlated subquery in the select list that would get that count for each department for each employee. And that's fine. Again, with this particular set of tables, a good old emp and dep, no big deal. There's 4 departments, there's 14 employees. You're probably not going to see a whole lot of, wow, that query really runs slow. But imagine a company with hundreds of departments and thousands of employees and, in each department. Now all of a sudden that running of that subquery, that correlated subquery over and over and over again for each employee starts to add up real fast. And even though it might do the count very quickly for each individual run, you're doing that run thousands, millions of times. That adds up real fast. Okay. So that's where the power of these CTs will typically really shine that, wow, all of a sudden I went from hours to minutes or hours to seconds for a query. All right, so I've been threatening to talk about this materialize hint. Here it is. So it has nothing to do with Star Trek, by the way, but I just like the little materialize thing. So anyway, the materialize hint, it effectively tells the optimizer, do not merge or inline this CTE back into the main code. Okay, so keep it as you can think of it as, keep it as a materialized view. Okay. So this will keep it as a separate entity, a separate thing. I don't know what word you like to use for that, and not merge it back into the main query, because that might be exactly what you don't want to have happen, right? So if we took something out of the main query to have it only run once instead of thousands of times, if it merges it or inlines it back in, we might be right back to where we were when we started, and we have no benefit. So one of the things I really strongly recommend is when you write CTEs initially, always use the materialize hint. Then test with and without the hint to see which one is better. Personal experience, materialize hint is almost always better. There are, of course, exceptions to that. So you want to test to find out what makes sense for your particular query. But the materialize hint is probably 90+% of the time going to be the right way to go. And even when it's not, it actually is the only reason you don't need the hint is because Oracle's materializing it anyway. And so you don't really need the hint. Now, how do I know if it's being materialized? Well, if you can look at that plan down at the bottom, um, you'll see that it says some kind of funny terms in there that you might not be used to from reading plans. It's temp table transformation, load as select, and then there's this really funny named object over there, systemp, blah, 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 blah. That is the CTE. So you know you've got a materialized CTE if it says load as select and then this strange name. By the way, here's a real fun tip about how to read those names of these CTEs. If you have multiple CTEs, the difference in the name is in the middle, not the end. Okay. So where it says like B7 in the middle of that one, the next one would be like B8. The next one would be like B9. And trust me, that threw me off for a long time. Which one is which? Because they look the same. Because I'm expecting the trailing part different, right? No, no, it's that middle part, the last part of the middle one, that actually changes from one to the other. I have no idea how the optimizer comes up with this name. Obviously, it's some sort of hexadecimal address to the location or something in the shared pool or whatever. Whatever. Who cares? But for us, all we need to know is that if you want to try to match up, because your CTs might get used in different places and you're trying to figure out, okay, which one is which, it's that middle part you want to look at to know which one is which. So little fun tip there. No extra charge, by the way. So anyway, so the materialize hint, by the way, there is an inline hint too. So if you want to force it to be inline, which rarely, but sometimes is a good idea, you can use the inline hint. That'll force it to actually push it back into the main query. I've probably run across less than a handful of times that the inline hint was actually, but yes, so you got both if uh, so some cases where CTs are really useful. I kind of beat up on that first one a bunch already, that correlated subqueries, and I'm going to touch on it one more time before we're done too. But that is clearly the best case use of CTEs. It really, really shines here. You take that thing that was running thousands or millions of times, do it once, and then refer to it just like it was a regular table. Amazing performance improvements. And I'm not kidding when I've seen queries go from hours to seconds by doing this kind of stuff. It's incredible. And I have actually rewritten a query that never completed when I started working on it. The folks were like, "We've never seen this complete." And I was like, "Okay." And I worked on it and rewrote it with CTs, and it was running in less than 20 minutes. And they had never seen it finish. They had let it run for days and never completed. And we got it to run. I'm not trying to say that because, oh, look how great I am. No, I saw other people do the same thing. I'm just trying to let you know this is the kind of power that you can get from these CTs. They are just incredible in that way. Another good use is pre-joining some tables. So this happens a lot. You've got a rather long list of tables in the front, 10, 20 tables in the front. And yeah, the optimizer is able to come up with a plan, but you kind of notice that it's not really joining the core tables together early in the plan. It's kind of like, doing this and the other thing. But it's like, hey, these three tables are really the core of the data that you want. And you'd like to shrink down and get to that core set of rows quickly. And the optimizer, for whatever reason, is not really following that path. Now, you could try with a whole bunch of fancy hints like the leading hint and this and that and try to force that to happen. Or, hey, how about we do this? Let's take that set of tables, which, by the way, is usually the first set of tables, right? Because what happens? You start writing a query, and what are the first tables you think of? The tables you're going to get the core data from. And then you think of, oh, yeah, by the way, I need that. I need this, dimensions of data as you put the rest of the query together. So yeah, usually take the first two, three tables. Let's isolate those, put those into a CTE, get that, working really well. And the great thing about CTEs also when you're doing this kind of work is you probably should test it as a standalone query. You want the CTEs to be able to run without the main query. You should be able to take, for the most part, a CTE out of the query and run it and see what happens. Now, realize this, the plan you get when you run it standalone may not be the plan you get when you put it back in the query. But if you get it running well as a standalone, there's a pretty good chance it's going to run really well when it's put back in the query. But when the optimizer sees a giant query, it thinks a little differently than when it sees a smaller query. I mean, obviously, thinking is probably the wrong word, but it approaches the query in a different way. So don't be surprised that the plan might be a little different. But let's take that set of tables, work on them, get them down to that core set. Now let's put that back in the query. Again, seen amazing results doing that kind of stuff. Um, a offshoot of that is the next one where we pre-process a table. We take a single table and we just process it first and then put it back into the query. Okay. Now with both of these techniques, the materialize hint is probably going to be required because you're probably only going to refer to that CTE once in the query. And if the optimizer sees that, often it is going to uh, inline a CTE that's only been referenced once. So a lot of times, and this is again why I state start with the materialized hint and then test with and without it to see which one's better. But for both of these two, you're probably only going to refer to that CTE once in the main query. So yeah, the materialized hint is probably going to be needed. Now the next one is one where you probably won't need the materialized hint because this is where you typically have like a large unioned query, 5, 6 union queries all, pushed together. But there's a common either subquery used in every one of those union clause or a common set of tables that is used in all of them. And instead of like, for example, running that subquery in every single union, let's run it once at the top and now refer to that data, in the queries, all the queries below it, uh, just like another table. And again, can have amazing results for performance for that. You probably won't have to use a materialize hint because it's being referred to more than once, and the optimizer will say, "Oh, okay, let me just leave that alone, and I'll just refer to it each subquery. Each time I need that subquery in each union clause, I'll just go back to that CTE." Um, there's something else I wanted to say about these. Oh, the set of tables. This one gets tricky because a lot of times we do use the same set of tables in many of the unions, but there's some different predicates in each one, right? Because we want this set of tables, but this one we want, people that are in Asia. This one we want people in England or whatever. It's different parts of the world or something like that. Okay, no problem. Let's see if getting the superset first, and then when I refer to that CTE down below, I add in those other predicates for each union. So I'm not running the join over and over again in each one. I've joined all the data together first, and now from that superset, I just select the piece I want out of that for each union query. Okay. So those are these are definitely not an inclusive list of times and places that CTs can be useful. Use your own ingenuity and imagination, so to speak, to figure out where there might be other cases to use these. And they're probably somewhat limitless in the places that you could attempt to use these. And you won't know if it's going to help or not until you try. And I run into this a lot of times where I'll say, "Hey, I think you probably ought to rewrite as a CT." And they're like, "Well, I don't know." It's like, "Well, did you try it? Let's just try it. I mean, we don't know if it's going to work or not until we try it. And yeah, sometimes it doesn't work. Okay, then that approach didn't work. Let's try something else. But until you run it, you don't know if it's going to work. Okay. Now, there's some exotic uses of CTs down here at the bottom. We've got the with functions. These are very cool, very high speed and all that stuff. Use them with caution, use them sparingly. You can define a function. You can also define procedures inside here too, although I don't know why you would. You can't refer to a procedure directly in SQL. I can't say select from procedure kind of thing. You can use functions. So I guess if you had multiple functions and they all had a common thing, you'd make that a procedure. It sounds complicated to me. But I wouldn't recommend using functions, with functions a lot. They very much need to be a one-off thing that's just very specific to the thing you're doing right now. Fine. But if it's a function, for example, that's going to be used in multiple queries, putting it in multiple queries is probably a bad idea because for code reusability, right, or code maintenance in the future, what if this function is in 50 statements? Yeah, now we need to change that function. Hmm. Did you get them all? Do you even know where they all are? Hmm. That could be a problem. So probably not do that kind of stuff. And recursive with, very cool for hierarchical queries. These can perform a little better than the good old starts with connect by syntax. So they're probably worth trying out if you're into big hierarchical queries. They tend to do a little bit less logical IOs in particular over the starts with connect by type syntax. Um, so they're kind of complicated. There's a couple different verbiages that you need to use. So it takes a little twist of the head to kind of get used to using them, but they can be useful. So some other neat things.
Yeah,
So,
before you jump on, there's a couple
yep,
of
okay.
questions that kind of came in.
Oh, yeah, I'm
So
sorry.
hopefully,
I haven't been keeping up with the questions.
yeah, easy one first, hopefully. So can CTs be cascaded? So like have first one, second one refers to the first one, and so on and so forth.
Absolutely. I slightly, let me jump back here. Kind of, I don't know if can you see my
Yeah,
pointer on the
we've
screen
got
here?
it. Yeah,
Okay.
yeah.
Yeah. So in here, I did mention, whoops, that's exactly what I didn't want to do. I did mention here that yes, this one could refer to CTE1, right? And three, if there was a third one, could refer to one and two. But you cannot do forward referencing. You cannot have CTE1 refer to two. They are processed in order. And that's another interesting point about CTEs. This does give SQL a little bit of procedural processing because CTE1 is going to run first, then CTE2, then CTE3, etc. So if you want to kind of force some procedural logic into your SQL, this is a way to do it because you cannot, when we write a SQL query, it's a statement. The optimizer can and will rearrange the statement as it sees fit to optimize that query and its, point of view, so to speak, to find that best query. So it's not going to run it. Oh, I'm going to process this table and this table. No, that's not necessarily going to happen. But if you want that to happen, hey, do this. CT1, then two, then three. Wow, yeah, yeah. Now I'm processing in order, which is one of the advantages of this. I didn't actually write this query, but a colleague of mine did this many years ago, where she took a query that they pre-processed data through three CTEs, doom, doom, doom,
Mm.
and then selected from the last one, cut the runtime by 60%. So the original query was doing it all at once, right? But they broke it out into multiple CTEs. So it said, okay, let's do this, and then we'll take that result and do this, and then we'll take that result and do this, and cut the runtime more than in half. It was, cut it by 60%. So that, and yes, I probably should have talked more about that on the slide, but yes, you can refer to them down the line. Yeah. I'm
Mm.
sorry.
Mm.
Next.
Yeah.
I'm
No,
sorry.
oh yeah, there's quite a few coming in. So
Uh-oh.
yeah, yeah, all
Floodgates are
right.
open.
Yeah, the flood people have started now, right? Actually, I'm gonna go with as we've got the materialize hint here. They're asking, are the predicates pushed into the CTE? For example, if I use the CTE in the view SQL and I query the view for a subset of the underlying data, will the CTE first materialize all the data before narrowing it down? So
I think I understand the question. Okay. Let me see.
I think
Where?
that's the most
Let me
recent
read it.
question that's come in.
Oh, okay. Materials and predicates pushed into the CT. Okay. No. Okay. Predicates don't get pushed into CTEs because each CTE runs alone, right?
Well, they don't if you use the
But
materialize hint. They do get pushed. They can get pushed in if you don't materialize it.
true, because the CTE could get pushed back into the main query,
Yeah,
and now it's part of the main query, and they would get pushed in.
yeah.
Yes, that's true. Um, Now, if you have a CT on a view,
Hmm.
could the that then predicates from the CT could get pushed into the view? Absolutely. If that's what you're asking. I'm not sure if I've got that right. But yeah, think of each CT as if it's materialized, especially. Each CTE is just a query on its own. So it would do all the things that would happen with a query. So if I select from a view and I've got predicates that can be pushed into the view, Oracle will try and do that. The optimizer will try and do that. Now, just because you have predicates on a view doesn't mean they will get pushed in. Uh, Generally speaking, for example, join predicates can't get pushed into a view. But if you have just a regular good old filter predicate like name equals Bob, that could get pushed in, certainly. Now, the optimizer has lots of rules about what it can and can't push in. There's, for example, if there's any sort of aggregation in the view, will not push in predicates because that could change the aggregation, right? So, yes, anything from the CTE could get pushed into a view that you refer to in the CTE, if that was the question. Is that how you read that,
Yeah, I'm not sure
Chris?
what the question about the view is. I think it's mostly just that if it's materialized, does it
Yeah.
prevent pushing? Which, as you say, yeah, it's standalone query essentially once you
Right.
materialized it, really, isn't
Yeah,
it?
but if there was a predicate in the main query that was being applied to the CTE,
Mm,
that's not going to get pushed up into the CTE.
mm,
All right. So if I say, I define my CTE, blah, 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 blah. And then in my main query, I say select from CTE where something in
mm.
the main query. That predicate will not get pushed up to the top because the CTE runs by itself first.
When
How
you
about the main?
materialize it, yeah,
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 if it's materialized, yeah,
yeah, yeah.
which we're kind of assuming from CTEs in a general way. So
Mm,
if the CTE runs as a materialized thing outside of the main query, none of the predicates from the main query are going to get pushed up into it because
mm,
it's treated as a separate standalone unit
mm,
and not, it doesn't look to see what's going on in the main query
Yeah.
for the most part.
Yeah.
Okay.
All right. So, and while we're
Uh,
also on Materialize, the interesting slash controversial question. So Materialize in inline hints are not documented, right? And some
that
people,
is true.
yeah. What's your take on this, or what do you?
Well, inline hint is for inline views, ILVs. The inline hint does not work with CTEs. The materialize hint is used for CTEs. In my testing, at least, the inline hint is not what you use for CTEs. You should use, wait, I'm back up. I'm thinking the wrong hint. Well, back
Yeah.
up. Yeah. So materialize hint, keeps it separate. Inline forces it to push back in. Um, yeah, these are the classic undocumented hints, and which there are many of. Um, and the trick with that is at any time, Oracle could decide that these work differently. Okay. So if you use them, which I actually recommend you do, just be aware that Oracle might change how they get implemented in the future. So I doubt it. I don't think these two are going to get changed.
Yeah.
At
I
least I
mean,
hope not, because it's going to really
yeah.
screw me up. Um, but yeah, they are undocumented. So there you go. And the reason Oracle does that is it's reserving the right to change the way they might function in the future. They might, work in the future. Um, hmm. So
Yeah.
use it with a grain of salt, use it with caution, whatever. I'd still recommend use the materializing personally. I use it all the time, twice on Sunday. No, I'm just kidding.
Yeah. They say. I mean, if you've got rules in place that say you can't use undocumented hints, then there's
And you can't use it. Yeah.
right.
Uh,
It's
but this is one of the, even, Tom Kite would recommend using the materialized hint back in the day. So it's certainly one that a lot of people have recommended over the years. So even though Oracle is still not documenting it, I gotta believe it's probably going to stay the same, and it's probably reasonably safe to use. But it's undocumented, so it could change in the future.
exactly,
Absolutely.
absolutely.
Yeah. I see the one about does it occupy space? I was actually going to
Hmm.
get to that at the end. So, but yes, they take up PGA space. So, as a matter of fact, I think I was almost there. So let me get back to my slides real quick here. We talked about that, talked about that. And, oh, I was about to talk about that. So let me hold off on the PGA space. I'm almost done with my slides, believe it or not. But let me talk about this because to me, this is the reason you use CTEs. Okay. So this is from an actual client that I worked at years ago. They had what each one of those things in the plan, over here, each one of these lines represents a correlated subquery they had in the query. Very common. They had many correlated subqueries. It was a unioned query. I'm not showing the unioned query part. These are just the CTEs. Um, or I'm sorry, just these became CTEs, but these are just the correlated subqueries. And each one of them you can see was running almost 10,000 times at the time I got there. And that was the problem with this query is that it kept taking longer and longer to run because as they added more and more data, what happens? The correlated subqueries run more and more often. So the query was taking about 10 minutes when I got there. And it was kind of getting it to be irritating for the users because they wanted this query to run a lot faster. And as time went by, it just kept getting longer and longer and longer. So we rewrote this, and it was not simple. I mean, each one of the correlated subqueries was relatively simple, a count or a min or a max or something like that. But there's a bunch of them. And you had to rewrite those as CTs and then reference them in the query and set up the joins correctly and all that. But the benefit was enormous. All of a sudden, we were down to 33 seconds to run this query that was taking over 10 minutes. Now, the cool thing about this, though, isn't so much that it now jumps to 33 seconds instead of 10 minutes, is that as this table grows, yes, the runtime is going to go up, a little bit, but not dramatically like it would have if they had left it as a bunch of correlated subqueries. I'm sure that this table has gotten larger, this was many years ago, so I'm sure the client is still adding data to their tables and stuff. And if they had left it with the correlated subqueries, this query, I wouldn't be surprised, would take 20 or 30 minutes to run. Whereas now with the CTEs, maybe it's up to 40 seconds, and you know. So sure, as you add lots more data, eventually even the CTE one is going to take a little longer to run, but it's going to, the rate of growth of that time is going to be very flat, whereas without the CTEs, it would be a very steep climb. So that's why these CTEs are so dramatic in their performance, is because they run once and then refer to the data instead of running over and over again. And again, each one of these correlated subqueries on an individual run was pretty fast, but add them all up, ouch, it takes a long time. So very, very, the most use of CTEs is with these correlated subqueries. That's where they really have their power. But again, if the correlated subquery is only running once anyway, don't bother turning it into a CTE. You're not gaining anything except the cool code you just wrote, which, maybe you can impress your friends and relatives with that, but you didn't help the performance at all. Okay. If it only runs a few times, again, the performance benefit may not even be there. So you want to look for those ones that are running thousands of times, and that's the ones that you want to attack. Okay, so let's talk about the memory space in particular. So these are recommendations by moi. They are not anything that the database or the optimizer enforces in any way, shape, or form. But these are things that I've gleaned over the years of using these things that I think are really good recommendations. And I'm not going to say that I, thought of them all on my own. These are just things I picked up using them with talking with other people over the years. One, try to keep the number of CTs relatively small. Think of 10 CTEs per statement as kind of a loose max. Don't, just creating more and more CTEs just because you can doesn't mean that that's better. You want to attack, if your subquery, I'm sorry, you have a query that has 15 correlated subqueries. Well, there might only be two of them in there that are really problematic. Those are the two you should attack and make into CTEs, not all 15 just because there's 15 correlated subqueries. Um, you want to focus, or one analogy, you want to rifle this. You want to shoot with, precision, not shotgun it and just, obliterate, all over the place. You want to, hey, let's focus on what's the problem and fix that, not just rewrite everything as a CTE just because you can. I mean, cool as that might be, you may not really help the performance any. So, don't do that. Keep the number of rows in each one relatively small. A million or less is probably a good idea. And this is where, testing them as a standalone is very helpful because I can run it. How many rows am I getting back for it? Okay. Can I shrink that somehow? Can I get fewer rows? And then lastly, only get the columns you need. I mean, this is generally speaking, you should always do this when writing any query, but do not use select star. Now, we can use select star. We want to just write a quick test, hey, select star from table, see if it exists or whatever. Yeah, that's fine. But when you're getting serious about writing a query, the select star syntax should not exist anywhere in your query. Everybody hear that? Okay, just check. You should never do that. And people will be like, well, I want to make sure it's, when I change it in the future, I don't have to figure out which. Well, if you're changing it in the future, you're changing it. So you should know which columns you're adding or whatever that you need now that you didn't need before. So take the time to do it right because this query is going to run, I presume, hundreds of thousands of times in the future. Taking an extra 10 minutes to figure out exactly which columns you need so that that query runs better those hundreds of thousands of times in the future is worth the time spent to figure out which columns you actually need. Now, why am I recommending all these things? And it gets back to the question about memory. Yes, if a CTE is materialized, which in a lot of ways, no matter how the CT is used, it gets materialized to a point because even if it's used in line, it's just like a view, right? A view, when you select from it, it has to get those rows and it still has to put them somewhere. Guess where that somewhere is? You got it, your PGA memory. Okay. So make sure these things are as small as possible. Now, if you find that creating a bunch of CTs, 16, 20 CTs, or a single CT that returns over 500 million rows, really dramatic performance, you take that query from hours to minutes, then it might, because, a query that runs for hours, guess what? It's taking up a lot of PGA space too. Uh-oh, I'm getting the dreaded internet connection is unstable. So
Oh, man.
if I drop,
Yeah,
just
yeah.
be
Okay.
that happened last time. So anyway, because a long run query still takes up a lot of PGA space. So just because you took up more PGA space for a short amount of time, yeah, that might be worth it because now I'm over and done and I've released the memory and everybody's good. So, but getting back to my recommendations, I would highly recommend that you keep these in mind as you're using the CTEs. And of course, the bottom of the slide is very important. You just got to test. You don't know until you know, and the only way to know is to test. Okay.
Yeah.
All right. And I'll go
Yeah.
to the last slide, which I'll let Chris talk about for a second, and then we'll jump back to the questions.
Yeah, okay. Well, I was going to say, so next month, we're going to be having for the office hours, towards the end of the year, I quite traditionally do like a design debate or classic design database design decisions. And it's your chance to kind of share your thoughts. Should we store date time values as a date or a timestamp, that kind of thing? We'll discuss them, we'll vote on the choices, and then at the end, I'll build the schema based on what the most popular choices are each time. So that's next month. We're normally every third Tuesday of the month, but I'm at DOAG. I'm in Nuremberg, and the third Tuesday next month, so it will be a week later than it normally would be. So I really enjoy these. I think we get a lot of good interaction from people for these. So please, if you're available, come join us and live to kind of talk and vote and see what we decide in the end.
Yeah, that sounds like it'll be a lot of fun. So I hope I can make it to that. So
Yeah,
um,
cool.
excellent. Great. All right, so now I'll jump back to our questions. Somebody asked about how Tom Kite is doing. He has gone dark on
He's
purpose.
enjoying.
He's trying to enjoy his retirement days and all that. So I respect that from him. The last time I saw him, which was a couple years before he retired, it was pretty clear he was pretty spent, and he was like, yeah, I need to get off this horse and relax. So I have not even attempted to try and contact him very much on purpose because I'm respecting his wishes to stay in the retirement and private life, keep it private. So I don't know how he's doing, but I don't know, Chris, if you've been in contact with him anytime recently. Yeah,
Uh,
I think he wants it exactly that way. So let's all try and keep it that way. If you happen to see him in the airport, sure, say hi to him. But I doubt he's even in airports anymore. I mean, he was so done with travel. It was crazy. But anyway, um, so let's see some other questions here. Okay, we
there's
talked
quite a
about the
few.
PGA space. Yeah, they don't really take up SGA space per se. It's the obviously the optimization and that running is in the SGA, but the storage of a materialized CT is in the PGA space.
So
Uh,
there's a few questions about this because there's someone
yeah.
asking that if we go up about PGA, SGA, and it's PGA, and someone saying at the end, "Are you sure it's PGA and not temp space, like temp disk?"
Well, it could be temp because if there's not enough PGA space, it's think of it when you do a sort, where does the sort happen?
Mm.
In
Yeah.
your PGA. If the sort is too big to fit in a PGA, where's it go? Temp space. So it's managed very similarly to that kind of thing. So it could go out to temp space, and that's again why you try to keep them small because if you got a 500 million row uh, CTE that's materialized, it's probably going to spool out to temp space. And so now we start talking about even, and of course, that is in effect going to slow down the CTE because now we're going out to disk, which of course
Mhm.
isn't disk like we used to talk about, but it's still slower than PGA memory space. So yeah, that's, again, another reason why we try to keep these CTs as small as possible. I see this one question about sample CTs from real customers. Well, generally speaking, I can't share those. But
Yeah.
no, so I don't really. I mean, I can at some point maybe, and maybe we'll do this in the future, and I'll give some example CTEs. We can maybe do that in a couple months where I write up, some ones that are at least representative of CTEs that I've done in the past. But yeah, generally speaking, I usually cannot show like customer code. That's
Yeah.
usually they frown on that. So,
Yeah.
and if
The
I want to have
example,
to get a whole bunch of approvals.
yeah, the example you had was a real example though, right? That's
Right.
a real
That was
customer
from a real
thing,
customer.
right?
Now, what I didn't show is the actual
Mm,
code that we used to
yeah.
rewrite. But yes, this slide back here, and we go back.
Mm,
Uh, Whoop, right there. This thing over here was from a SQL monitor of the actual customer. And I purposely, shrank everything so you have no idea of the table names or any predicates or anything. So there's no way to figure out what this is. Okay, great. You did a sort aggregate.
mhm.
Whoop-de-doo-dah. What's that? A min, a max, who knows? So yeah. CTEs and an update clause can also make things easier. Yeah, CTEs, well, okay, so here's the caveat with CTEs. CTEs can only be in selects. Okay. Now, that doesn't mean it can't be part of a select of an update. That can happen, but they can only be in a select. Okay. So you can't have up or with update. What? That doesn't
Mhm.
work. But you can have update, and then when you start the select, the first word might be with, and then da, 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 da. Okay. So yes, updates, inserts, deletes can have with clauses, but they are part of the select in the DML statement, but they are only valid in a select statement. So keep that in mind. Um, Using a CT in a handful of columns and later.
Yeah. So I
No,
guess
no select star.
well,
Just
hang on. I actually agree with the customer on this one.
no, I don't.
No. You've got chained CTEs. You've got CTE one and
Yeah,
CTE
yeah, I
CTE
hear
one,
you.
and you've selected all your columns in CTE one. I think select star in the second one is fine, right? I think that's fine because you know you've already selected them all once.
Okay, I
Mhm.
will let it pass, but I'm just not a fan of select star because and here's why. I spend most of my time debugging code,
Mm,
not writing, just debugging. When I'm debugging something and I see, like let's say that the one CTE is a problem and it's got the select star in it. I'm like,
mm,
what are the columns in here?
mm.
Okay, yes, I can figure it out. I'll look up here. Okay, here are the columns. Is it really that hard to put the column list in the CTE?
I
No,
mean,
it's not. You can do it. It's
well,
okay. You can
I
do it.
mean, you can do it, but
I have
if there's
faith
a
in you.
hundred,
You can do it.
if there's a hundred, is that easier? I don't know. Anyway, I just, I
How
think,
many times are you going to do that?
not that
Now
often.
there's once. One time you're gonna write that list of columns.
Oh no, yeah, no, it's not writing it; it's looking at it because it fill the screen, go off the edge. You can't even see the columns, right? I think that's my point.
Yeah, all right.
Yeah.
Yeah, yeah,
When
yeah,
you've got
yeah.
like 100 columns or more, they don't even fit on the screen, and then,
Oh,
right?
I hear you, and I get it, but I'm still not a fan.
Yeah,
I still like, and again, because I spend most of my time debugging code,
mm, yeah,
it's and like I love aliases, but I hate aliases that are A,
yeah.
B,
I think,
C. Why do we do that? Because it's easy. I hate when you reuse aliases. Like you have multiple CTs and you use the same table maybe in each CT and you alias it the same way each time.
Mm.
Please don't do that. Alias it, it's fine. Maybe, it's a three-letter alias, okay? ABC1, then ABC2, ABC3. Why? Because when I'm reading the ex execution plan and it uses the aliases there, I
Mm.
don't, it says ABC dot whatever column name. Which one of them is that? You know,
Mhm.
I don't know. Okay. And it can be very frustrating, again, because I'm coming from a debugging background, not a
Mm.
code writing background. Your things use unique aliases as much as possible. If you use the same table 5 times in a query, no problem. I understand we got to do that, but use a different alias each time, please,
Yeah.
please. Thank you. Okay. All right. We're getting off to
Yeah, yeah, yeah.
uh distributed queries, remote tables, blah blah blah. Well, okay, yeah, remote queries offer a whole lot of fun stuff. It's where's the query going to run is the problem, right? So Oracle wants to run the query where most of the data is, and we can use the driving site to help it know that most of the data is over there, not here, and that kind of stuff. So yes, CTs could be a good idea. Is it always, nothing is, the greatest thing about Oracle is its flexibility. The worst thing about Oracle is its flexibility, right?
Yeah.
So could CTs be a great idea? Absolutely. Could they be a horrible die? Yeah, that could be that too. So I can't say that, oh, yes, it's the classic Oracle answer. It depends. You'll have to test it to find out. And just because this query worked great that was distributed with some CTs doesn't mean the next one will. So be careful about making any sort of assumptions that this is always good. It's like even materializing. I highly recommend you materialize your CTs, but is it always a good idea? Absolutely not. There are plenty where running it with an inline, basically having the optimizer inline, it works fine. Uh, More cases than not, that happens to not be true, i.e., the materialize usually is a better idea, but that doesn't mean it always is. And I've had a few, and again, less than a handful of queries where the inline turned out to be a great idea, which, kind of blows my mind some when I run into that because that's just counter to what I expect. But it worked better here. So there we go. You
So I think there's one question came in a while ago when you're
oh,
talking about
okay.
the PL SQL, the PL SQL with functions.
Oh yeah, the with
Yeah,
functions.
yeah. So the question is, is there context switching still when we have
Yeah.
that?
Uh, yes, because there's always a context switch between SQL and PL SQL. Now, what is interesting is that from my tests, and I can't really figure out exactly what's going on here, but a function can sometimes run much better, i.e., faster as a with function as opposed to a standalone function. Typically, this looks like because A, it's a simple function, and it's a function that could be what's the word they use for functions? Where the function gets inserted into the code. It's not
Inline?
in,
No, I'm not sure. I'm not sure. If it's not inlined, I'm not sure what you're thinking of.
yeah, maybe it is just inline, but it's a function that is simple enough that Oracle can just it just becomes part of the SQL statement. And it's not really the external function call that usually happens. And
Oh, you still with us, Rick? Or have you gone?
gosh, I just can't remember the name for that technique. But anyway, so sorry.
No, sorry, you just broke up a bit there.
Oh, okay. Well, I have to tell you, I'm a little
Yeah,
unstable.
yeah, yeah. You just stay with us for a couple more minutes, right?
Yeah. So it's possible that a function could run faster as a with function than as a standalone, but it would be a very, very simple function typically. If it's a function that's doing a lot of fun stuff, it's probably not going to have much difference
Yeah.
being standalone versus a with function. from my personal tests. And I know, oh, I just forgot his name, who did a lot of tests on this too. Shoot, I'll think of it later, probably after this presentation. But
Yeah.
I would just be cautious with functions. They look cool and they sound cool, but they can be a maintenance nightmare. So just
Mm,
be careful with them. A lot of shops basically forbid them because they've had too many issues with trying to work with the code later.
mm,
It's a maintenance. It's like writing recursive code. People think, oh, I'll write a recursive code. And it's like, that is such a pain in the neck to maintain later that, recursive coding is a lot of times forbidden at a lot of shops.
yeah. So I've got another
Um,
interesting
Go ahead.
question. Would you recommend using CTEs to select from a collection type and materialize the data instead of using from table name? So, like a table function, I guess. I'm assuming what
Yeah.
we're referring to here. So,
Honestly, I'm not sure. I've never tried that, so I can't speak to that with any level of confidence. I would say it's definitely worth a try.
hmm,
Uh, Especially again if that from table clause potentially gets re-executed,
hmm,
yeah, then doing it once rather than over and over again. And so that's the key you want to look for. Again, I'll go back to this slide since it's still up here. The key here is that number right there, right? That 9,000 number is the like, okay, we got to do something. If you've got a thing in the code that is just running once, it's executions or runs, depending on, there's different names for that column depending on which tool you're looking at. But if the executions column is a one, like up here, well, turning that thing, whatever it is, into a CT is probably not going to help. But if it's a thing running lots of times, that's an indicator that a CT could help. Um, but so if you've got a table function that you can tie to a point in the execution plan that's being re-executed, moving that to a CTE sounds like a reasonable idea that it could be helpful. But just to move a table function into a CTE just because, I'm not sure. I've never tried that. I doubt that it would be better because the table function is still going to run. It just runs in the CTE, and now you refer to the set. If it only ran once to begin with, I'm not sure that's helping any. I hope that gives, but
okay.
I've never personally tried that, so I can't speak to it. Chris, have you ever
I've
toyed
not
around?
tried that. I did want to say something else on this though quickly because they're saying if the optimizer is not finding out the size of the collection, so the optimizer
Oh, right. Oh, that's a
traditionally.
good point. Yeah,
So hang
that could
on,
be.
yeah, I say that something I will say is there's something that's come in a recent release update. So 23.8 is dynamic stats on these PL/SQL
Mhm.
functions. So from 23.8, you can actually allow the optimizer to get good row estimates for these
Yeah,
table functions. So
yeah.
that's quite a new feature. I'm pretty sure it's 23.8 anyway. So um, yeah, that's something, when you're fully patched and up to date, you'll be able to use. In the meantime, then yes, this might be
Yeah,
something to
and
look.
that is a very good point because that is kind of another little offshoot of CTEs where I've used it. You put in like the cardinality hint in the CTE to say, hey, by the way, the CTE is going to return. Because again, Oracle's trying to estimate the rows are coming back from the CTE, and it might get that wrong. Um, and you can use the cardinality hint to at least get it in the right direction. And that's been very helpful. And that could be a case where you might have, again, a set of tables that are getting joined together, and the optimizer is really not estimating that set correctly. So you pull it out, put it in CT, and give it, the cardinality hint. Now, the bad side of the cardinality hint is that it's a fixed value, right? So you say cardinality of 100, that doesn't necessarily mean it means exactly 100, but it means around 100 rows. Well, it's always going to think that. So if it's now returning 10,000 rows, it's still going to think, well, it's returning around 100. And you can't dynamically set the cardinality unless you have completely dynamic SQL, which enters into a whole new uh, world, so to speak. But the cardinality can be helpful, especially if the CT is relatively static in size. You know that it's always going to return about this number of rows. Cool. put that in there. So that is, yeah, you're right, Chris. That could be a very useful case for the table function kind of thing where the optimizer really just has no idea because I think it just estimates about 8,000 rows with an 8K
Mm.
block size, right? So,
Yeah,
um,
something like that.
yeah.
Yeah. All right. We've got quite a lot of questions. Unfortunately, I do have to head off pretty soon.
Yep,
So I think
yep.
we've probably got, do you want to pick one last question to answer, Rick? And
Let's
then
see.
I think so I guess someone was asking, I think, was there a possible case where CTE can decrease the performance of the query? I think that's probably a good
Certainly.
one to think about, right?
Yeah, yeah. Any tool can be misused and you could make things worse. That's why, especially testing the CT as a standalone to make sure it's actually running well is important. Again, just because you use CTs does not automatically mean better performance. I've seen queries get worse because of CTs. Yeah. You just pick the wrong set of tables that you use or something like that. Or again, you focused on the wrong part of the query. You didn't find was running of times you thought, oh, and this is let the numbers lead you to where the problem is. Don't assume anything, right? A lot of people like to say, oh, there's a full table scan. That's bad. No, stop that. Okay. Maybe it's bad, but I've seen indexes work worse. Oh, let me start that again. I've seen indexes have much worse performance than a full table scan, especially with Exadata. So don't assume by the name of the step that this is a good or bad thing. Numbers. Look at, the execution count, especially when you're trying to figure out where's a bad part in the plan. It's a great place to start. Where's the plan? I don't show this in this one, but there's an activity line, activity bar that's over on the far right. That's a best way to figure out where's all the work in my query going. Where's all the activity happening? Focus on that. If you focus on the wrong thing and rewrite that as a CT, yes, you can make performance worse. So every tool has good and bad things. Just there's if there was one thing that fixed it all queries would be written that way and we'd be done. We'd have a job. So um, nothing works for everything. Yeah.
Yeah.
Um,
Right. Like I say, I do have
yeah, and
to
I,
head
I
off
just
today.
I do want
But
to just comment. I see
one
a
last
couple.
thing. Yeah, go
Yeah,
on.
one last thing. I see a couple questions about indexing and CTEs. That would be cool. I got to admit, it would be neat if dynamically created an index on CT. I don't foresee that happening anytime soon, especially with the way Exadata and whatnot and full object scans are working. I don't foresee that happening, but that would be cool. I would be pretty neat if there was like an index clause with your CTEs and say, hey, index this column when you create the CTE. I agree that would be pretty nifty, but I don't foresee that happening now. I don't have a hotline to the guys in the optimizer group, so I don't know if they're working on that or not. That'd be really neat if they were, but I don't foresee that anytime soon for sure. Anyway,
Mm.
I know you got to run, Chris. It was a great time with you again, and we'll look forward to maybe doing another one, and maybe we'll talk about yeah, some actual examples of CTs and kind of say before and after and stuff like that. So,
That'd be
all
cool.
right. Thank you,
Yeah.
everybody. Have a
Well,
great day.
glad you could join us, Rick. And like I say, hope you can all join me 25th of November. So same
Yeah,
time
that's
in 4 weeks, I think, or 4 or 5 weeks.
that sounds like it'll be a fun time. So,
All right then.
all right.
Thank you. And thanks for joining us, Rick. Okay.